Hello students, in today's video we are going to see the classification of oxides. Now, before going for the classification, let us first understand what is the meaning of oxides. Here the term oxides is related to oxygen. Oxygen combines with large number of metals and non-metals to form binary compounds called as oxides. So simple meaning here is when oxygen reacts with or combines with any metal or a non-metal, then its corresponding oxide is formed. Now, depending upon the type of the oxide it forms, we classify those oxides in 4 types. Now, what are the 4 types? So, before writing the classification, let us understand the oxides one by one. So, the first oxide, what it forms is the acidic oxide. Now, what is the meaning of acidic? Acidic means when this oxide which is formed is dissolved in water. If it gives an acid, then it is called an acidic oxide. So, oxides that combines with water to give acid, they are acidic oxides. Now students, when this type of oxides will be formed, so usually when oxygen combines with a non-metal, then it gives an acidic oxide. So this is very important to note that acidic oxides, they are formed by the combination of oxygen and non-metals. Now the question is, where are the non-metals? For that, let us take a quick glance on the periodic table. If I try to draw the rough skeleton of the periodic table, what you have here is the S block. Now I am not drawing the complete periodic table, but just a glance on how the periodic table looks like is this. So you have this as S and this as P block. Students, all the elements which are present in the first and the second group, they are non-metals. Sorry, they are metals. And when I say they are metals, they will form basic oxides. Now as I move on to this side, excluding the zero group elements, all the elements when they will combine with the oxygen, they will form acidic oxides. Because those elements, they are non-metals. So what you conclude from here, which elements you have here, they are usually the halogens, oxygen family, nitrogen family. So they all will have the acidic oxides. You know sulfuric acid, nitric acid. So the central atom there is sulfur, nitrogen, phosphoric acid. If I say there is phosphorus. So they all are from this P block. So the elements which are present extreme to this side, they will form acidic oxides as they are non-metals. And here, if I see on this side, the first and the second group elements, the S block elements, they are metals and their oxides will be basic oxides. So let us see some of the examples of acidic oxides. So the acidic oxides, the examples will be, let us start from group 14. So it will be carbon dioxide. You have B2O3 also. It will form the boric acid and we will see this later on. So next is N2O5, SO2, SO3, Cl2O7. This is chlorine heptaoxide. So let us see whether they are, when dissolved in water or when they react or combine with water, whether they are forming the acids. So let us try first for this. So carbon dioxide plus water. What it will give you? Simply it is a combination reaction, students. So you have to write H2CO3. So what you will get is H2, then C and O3. This is carbonic acid and this is an acid. Therefore, carbon dioxide is an acidic oxide. Similarly, move on to SO3. When I dissolve this in water, what I will get is H2SO4. This is sulfuric acid. So this is again a combination reaction, H2S and O4. So you get this. Let us go for P4. This is also phosphorus is from 15th group. So O10 plus H2O. So what you get here, student, is phosphoric acid. That is H3PO4. Let's balance the equation. I think this will be 4 and this will be 6. So this is again acidic oxide. Come to N2O5 and add this to water. Which acid you will get here is nitric acid. Let us balance this. So it will be 2HNO3. How much is this? Is 2 moles of nitric acid. So here N2O5 or nitrogen pentoxide is also a acidic oxide. Let us go for Cl2O7. If I add this to water, so what I will get is perchloric acid. That is this. This is perchloric acid. So if you see this in all, when the non-metals usually have the oxides, they combine with water and they give this type of substances. So we call them as acidic oxides. Let us come to the next one, that is basic oxides. Now what is the definition, students? You think oxides that combines with water to form a base. They are called as basic oxides. Usually electropositive species or metals. Usually electropositive metals combine with oxygen to form this, right? And usually one very important thing here, you know that when oxygen is the second most electronegative element in the periodic table, and when I am talking about metals, they are on the extreme or your extreme left hand side, so the electronegativity difference is high, and therefore those basic oxides, they are usually ionic in nature. So you can say that basic oxides, they are ionic in nature. Let us take some examples here. You have second group elements or first group elements. So let us start. Calcium oxide, you have sodium oxide, potassium oxide, you can have magnesium oxide. So let us try one by one. Calcium oxide, when combines with water, what you get is calcium hydroxide. So this is the example of a basic oxide. Students, what I will get if I dissolve this in water, Na2O, if I add this to water, you will get NaOH. If I take barium hydroxide, I have not written here, so this is barium oxide plus water. So what I will get? Barium hydroxide. So those are all basic oxides which are usually with the oxides of metals or electropositive metals. The third type of oxides, they are amphoteric oxides. Now the word amphoteric is from amphibian, students, means having properties of both. Oxides will show both acidic as well as basic characteristics. So let us see the definition for this. Oxides I'll remove this paper. Yes. Oxides which show both acidic and basic characteristics. Right, students? Now, these oxides, they react with acids as well as bases. So, when they will react with, so I will just write they react with acids as well as bases to form salts. They form salts. So they are formed by the elements that lie between metals and non-metals. Right, students? So how they are formed? They are formed by elements that lie between metals and non-metals. So this is about the amphoteric oxides. Now the examples for this, usually we have the examples of aluminium and zinc. So let us see how they react with the acid first and then with the base. So let us see both the equations. So I am taking aluminium oxide L2O3 and first let us react this with HCl. So what product you will get here is aluminium chloride and water. So this is the salt which is formed, that is aluminium chloride. Let us balance the equation, student. This will be 6 and this will be 2. So I will write the physical state here as aqueous. So this is the first reaction where now here if this is an oxide, it is reacting with an acid, means it is acting as a basic oxide. So here it is a basic oxide. Now let us see what happens when it reacts with a base. So the second reaction is L2O3. Let us take the base as NaOH. So first you have to remove water. So what you will get here, I am removing water and then remaining I will write here. So what things are remaining now? For that, let us take the 6 moles according to the valency of aluminium. So I will write 6 here. So when I remove water here, so let us remove water first. So what I will get here is 2Na 3 AlOH6. So this what I have removed here, I can add to this side. So what reaction I get? L2O3 plus 6 NaOH. I will make this aqueous. So it will be 3H2O gives 2Na3 AlOH 6 times. So this is what will be the salt which is formed. Let us try for the next one, that is zinc. So zinc oxide when combines with HCl, valency of zinc is 2. So I will take here 2 moles of HCl and it will give me ZnCl2 plus water. Right? And similarly ZnO when it combines with NaOH, I will take 2 moles again. So it will give me the salt, that is Na2ZnO2 plus water. So this is what the amphoteric oxides are. And there are few more oxides, the oxides of which they are neither acidic nor basic. So the fourth category of this, they are called as the neutral oxides. What is neutral oxide, students? Oxides which are neither acidic nor basic. And the examples here, there are only 3, that is NO, N2O and CO. So only 3 examples for this neutral oxide. We have few more for amphoteric. You can have here, like I had aluminium oxide, you can have silicon oxide. So amphoteric examples we have L2O3. The first example you have silicon oxide Second, I think zinc oxide we have taken. You have lead oxide, then stannous oxide, that is tin oxide you have. So those are the amphoteric oxides and those are the neutral oxides. Now as I have shown you the periodic table, now let us see what should be the strength of the acidic and the basic oxides. For that, let us come back to the periodic table. If you see the periodic table, students, here what I have, the sodium, I will start for sodium, magnesium, aluminium, silicon, because most of the examples we have selected from this. So I am writing now Na2O, this is the first oxide. Next is MgO, L2O3, SiO2, P4O10, SO2 and Cl2O or Cl2O7. Now what will happen, students, as I move from this end to that end, what happens to electronegativity will go on increasing. So as the electronegativity will go on increasing, what will happen to this side? To this side, oxides, they will become more and more acidic. So here if I see this, how I can name this? So that acidic character will go on increasing on this side. So this will be strongly basic. I can call this as basic, right? Now here if I see, they are strongly acidic. I can call this as acidic and this as weakly acidic and this as amphoteric. So as you are moving towards S side, S block elements, they become more and more basic. But as you move on to the P side elements, then P block elements, then you get a strong and strong acidic oxide. So this is all about the type of oxides, the four types what we have studied: acidic oxide, basic oxide, amphoteric and neutral oxides. I hope you like this video. So please subscribe my channel, like the video and share it with your friends. Thank you, students.